Hi, everybody. Today we're going to learn about the demographic transition model. You read about it. Hopefully it makes sense to you, but I'll go over some of the finer points today, and hopefully it'll make even more sense. All right, let me just share my screen with you. I should also note that I'm in the city, and you'll probably hear noises coming from afar at some point. So just ignore that. All right, so today we're looking at this thing called the demographic transition model, and I'll get to that rhyme on the bottom of the screen in a second. For now, let's look at this word demography. Hopefully you know this is the study of population statistics. So this is a model that goes over a transition in population statistics. Specifically, it's going to go over a transition in birth and death rates, two very important statistics that countries keep a close eye on, at least if they can, and if they find something disturbing, they will try and do something about it. So birth and death rates obviously very important to a country. More people you have dying, the greater the problem that is. The faster the growth rate of your country, the more significant that problem is. And of course, the opposite can be true. If your country's shrinking, that could be a problem. So there's 5 stages to this, and this rhyme at the bottom of the screen will hopefully help you remember the demographic transition model far into the future. This is the basic summary of what the demographic transition model entails. Deaths decrease or stay the same, and this is true till the 5th stage. Births decrease or just remain, and this will never see a change. Hopefully that makes sense to you. Births will always go down or stay the same, and deaths will do the same thing until you get to this 5th stage. So if they're not going to go down or stay the same in the 5th stage, what would you guess happens? Hopefully you can guess that they go up. This rhyme may help you as we go forward. But let's dive into some of the more detailed parts of the demographic transition model. We're going to go stage by stage. And first thing we'll cover is what this is. Well, as I already told you, it's a 4-stage graph, although there's actually a 5th stage that shows the pattern of society's change in birth and death rates and the resulting population growth. So if you look at this chart, you can see the death rates are in green. I'll kind of trace them with this red pencil. And you can see that generally they are roughly about the same in stage 1. They're not going anywhere. Stage 2, they go through this huge drop. Stage 3, they continue to drop a bit. Then stage 4, they're about the same. And eventually we'll add stage 5. Birth rates, on the other hand, we'll do in green. It's kind of like adding people. Those are also basically staying the same. And they're still staying the same. And then they see a big drop. And then they are basically the same until the 5th stage. The resulting population change that comes from this, well, when you have your birth and death rate basically the same, your population is not really going to grow. When you've got a big gap between your birth rate and your death rate, with your birth rate being higher, hopefully you can guess that your population is going to increase. As that gap persists but decreases, you'll see that population increase continue but start to taper off. And then once again, just like in the 1st stage, when your birth and death rates are basically the same, you should see your population growth level off. So hopefully that makes a bit more sense to you. But the chart then is going to be followed by many countries. I shouldn't say they'll follow it. It's not like they do it on purpose. It just happens by countries, cities, regions in general as time passes. So what else is there to know about this? Well, generally, as I've told you, death rates tend to go down first. And as a country develops, their birth rates will eventually also go down. There's a reason why death rates tend to go down before birth rates. We'll try and get into those a bit later, but the short summary is that people always want to live longer, for the most part. I don't think there are many people out there that say, yeah, I want to live a shorter life. But if you ask people, well, hey, do you want to have less kids than you want to have? That's a very personal choice, and it's going to vary from person to person. I mean, right now, if I say that I want 2 kids, and somebody tries to convince me to have 1 or 0, it's going to be a hard convincing job. So birth rates are harder to decrease, and that's why they happen later. But if somebody said to me, hey, do you want to live to 120 instead of 80? I would say, yeah, probably. That sounds great. So death rates generally decrease first, and then birth rates follow later. This whole transition has affected the globe in a major way over the last 200 years or so. As you can see in this chart on the bottom, it's a bit small, but this chart is showing us the world's population as of the year 1000. And you can see that our population on the left by billions goes as high as, oh, it looks like 10 million up here. So this is kind of taking us into the future, but this is 8 million. You may know right now we're about 7.5 billion. So about 1,000 years ago, the world's population was barely at maybe 200 million. And that's kind of how it remained for a long, long time. You can see that the population really basically stayed at this same level with low growth. In other words, most of the world, or all of the world, actually was in stage 1. Basically, no difference between birth and death rate means very little population growth. But starting somewhere around here-ish, call it 1800, the world's population starts to suddenly grow very, very quickly and gets faster and faster to the point where over 200 years we went from about 1 billion people. We reached 1 billion in the world roughly around 1805-ish, to 200 years later having 7 times that many people. And this, of course, creates an alarming circumstance. You may ask yourself a question, well, how many people can the Earth hold? There's obviously no good way to answer this question, but if I ask you to work backwards, I mean, can the Earth hold 1 trillion people? I don't think so. Can it hold 500 billion? I don't think so. I mean, we're doing pretty bad right now with 7 billion and the way the Earth's being destroyed. So can it hold double what it's currently got? Maybe. I don't know. I mean, we got the space for them, but will people be happy and will we be able to provide for everyone in a decent way? I don't know. Is the Earth going to be in good shape? I don't know. So the faster the population grew over the last 200 years, the more people got concerned. And this started in other places. It wasn't like global everywhere. But this is really what the chart on top is trying to get at. All of this stuff leads to this. And of course, after, well, anytime after today, looking far into the future, like 50 years from now, the question is, what happens? Does it continue to go up? Do we all sort of start to compete for resources as a species until only a certain few people are able to dominate the globe and many people are left to suffer? Some may say we're like that right now. Huge, huge questions, obviously. So before we get too depressed about the state of the world, let's move on. I've given you this rhyme already. Hopefully it's got more significance to you now at this point, but again, deaths decrease or stay the same, and this is true till the 5th stage. Births decrease or just remain, and this will never see a change. A slightly more in-depth view of that chart shows you some of the major events that caused the change. So this stage 1 is generally deemed to be the pre-industrial era. This is kind of true up until the mid-1700s, let's say. The early industrial age in stage 2 kind of starts to happen in the mid-1700s, and this is when humans start to develop machinery. And then hard to say exactly when this mature industrial stage begins, but I'll say like the maybe mid-1900s-ish. And post-industrial kind of gets us to today. Maybe you could say the 2000s to the present, but these are all kind of rough figures. Through these stages, you can see that the growth, again, is slow and slow when the birth rate and death rate are the same and the same in stage 1 and 4. But then we see the most rapid growth when the death rate drops in stage 2, and then slowing growth as the birth rate eventually matches the death rate or close to it at the end of stage 3. So many countries in the world today are somewhere in stage 2 or 3. The most advanced countries in the world are somewhere in stage 4 or 5. And thankfully, no one in the world is in stage 1. That would be a pretty poor condition to be in, where you have high birth rates, high death rates. Generally, all countries in the world today have a relatively low death rate, emphasis on relatively compared to the past. So skipping all this stuff because I think we've talked about it. Hopefully you've identified the stages that you see growth in, stage 2 and stage 3. whereas stage 1 and stage 4 have low or no growth. And we could look at a quick view of the world and see how this plays out today. So looking at these charts, the top chart being CBR and the bottom chart being CDR, so that's birth rate on top and death rate on the bottom. We've got some nice choropleth maps here. You may recall a choropleth map is one that shows a statistic or statistics using different shades of colors. Could be one color in multiple shades or multiple colors in different shades. This map on the top appropriately shows us the highest birth rates in the darkest color, the reddest color. Red is kind of alarming, so this is a good choice by the cartographer. And you can see generally the world's fastest growth rates are in sub-Saharan Africa. In terms of birth rates, that is. Shouldn't say growth rates. Alternatively, the slowest birth rates, or the lowest, are here in places like Western Europe and Europe in general, as well as places like Japan. Now let's see how that compares to the death rates. You might be able to guess that a country that has a high death rate probably is not doing so well, whereas a country with a low death rate probably is doing just fine. So let's see if that's true on this really nice choropleth map on the bottom. Looks like certainly the highest death rates are in the same kinds of areas that we see the highest birth rates. We may be able to figure out some reasons why that is. But then when we look at the lowest death rates, it seems like countries that are really wealthy, like Western Europe or the United States, actually aren't doing so hot. We're doing okay. I guess America on this chart is better than Western Europe. But we may ask ourselves, well, why are there so many people dying sort of in Western Europe when they're so wealthy? So we'll get to that question, but the sort of point that I want to make here is that generally the poorest parts of the world have the highest birth rates and the highest death rates. And generally, the richer parts of the world have the lowest death rates and the lowest birth rates. It's not always true, but that's generally true. Let's move on. Looking at stage 1, hopefully you recall that this is where all humans were until the late 1700s. And when you have a high birth rate and a high death rate, hopefully you recall that that means there is basically no growth. So why were birth rates so high? Lots of reasons. A lot of the same reasons why death rates were so high. Birth rates were high because, well, death rates were high. If you were farming for a living, as everyone was, or most people were for most of human history, you would need a lot of people to farm your farm. You didn't have machines to help you. So a family would often have many children, and that would help you make ends meet. As soon as those kids could walk, they would be farming. But you would also have a high number of kids that would die. Even in Chicago up until the late 1800s, about half of the kids that were born in Chicago would not live to see the age of 5. This was in the late 1800s. Pretty shocking, only about 150 years ago or so. So what would you do to make up for the fact that kids have this tendency to die? You would have more kids. Makes sense. So high death rates kind of lead to high birth rates in many ways, but also the job that people did, farming, again, necessitates that people had larger families because they wouldn't be able to have machinery to help them. That had not been invented yet, generally. So often those two things are linked together, birth rates and death rates. Thankfully, as I've mentioned earlier, no countries in this stage today, but local areas might be. And if you go to a place where maybe there's a crisis happening like a civil war, like in Syria, I bet you have places where the death rate is high. Birth rate might also be high, but generally this is not very common today. So if you have a high CDR, or CBR rather, and a low CDR, a high birth rate and a low death rate, you should have high natural increase rate, or rate of natural increase, and something else, which we'll figure out in a minute. But let's look at how this chart then changes in stage 2. Again, remember that in stage 2, your death rate has decreased, and you now have a gap between your birth rate and your death rate. So you've got high growth. This high growth will generally be occurring in the poorer nations of the world, the less developed nations. I won't call them undeveloped, even though that's what it says on there. I'll say less developed. And those birth rates are going to remain high for a bunch of reasons. Of course, women are the ones who have kids, and women will generally have less access to birth control in these time periods or in poorer countries in general. In many cases, it's customary for women to have many kids. Many people have had many kids for a long, long time. That's just how it is. It's what women do, especially when they don't have a job to go to every day. Which brings up my next point about women having few opportunities. One of the major reasons why birth rates are eventually going to decrease is because women will have something else to do. That's not to say that women have been sitting around for most of human history. Generally, women today constitute most of the farmers in the poorer countries of the world. They do a lot of the farm work, and of course they also look after families. So they have work to do, but it's not the same kind of work as, like, going away to a job, working in a factory or an office. Those types of things, of course, often come with education. So if women are given these same opportunities that men have had for many hundreds of years, the opportunity to go somewhere to work or get educated and work in an office, they often end up postponing the childbearing years of their life and having less kids in general overall. Of course, then the opposite is true. If you have women that are less educated, they probably will fall into this customary role of staying at home, looking after kids, having kids, and probably also doing work like farm work. So this is generally true for poor people in the world where women just don't have much else to do other than these traditional roles. Eventually, this will change. The death rate, that is, will change due to some huge advances. So if we've explained kind of why the birth rate will change eventually in stage 3, why is the death rate dropping in stage 2? Well, it's because of this event called the Industrial Revolution, and something that will happen kind of at the same time and continue on later along with the Industrial Revolution, known as the Medical Revolution. It's kind of what it sounds like. If you know that the root word of industrial is industry, you may know that that means things like factories and machines, whereas medical, of course, has to do with medicines. So if you have machines that enable more food production, for example, like this thing you see in the corner down here called a seed drill, which basically spaces seeds for you evenly, so you don't have to plant them by hand and maybe space them inefficiently so that not every seed gets equal access to soil, water, or sunlight, but now with the seed drill they do. This means you're going to get more productive crops, and this will produce more food for you. You might also have efficient meat packing, so that meat will not be a rare thing for people to eat anymore. Of course, meat today is very cheap because we have efficient meat packing, but it used to be up until the mid-1800s that meat was reserved, even in the richest countries, meat was reserved for special occasions like Christmas. So if you have more efficient meat packing, people are going to be able to have high calorie foods like starches, like, well, meat, of course, creates protein, but you'll also have seed drills producing things more cheaply like corn, high starchy foods. The wheat reaper will do a similar thing for wheat, which used to be a hard crop to harvest and grow. And then these improvements in medical care will help people live longer as well. You've got things like vaccines, medicines like penicillin, and improvements in medical care in general, cleaner facilities. And eventually you can add into that better transportation and communication. So not only is it enough to, not only is it helpful to produce more food for people or more medicines, but better transportation allows you to get those things to more people. So you've got these two or three major features that are going to result in death rates dropping. More food generally makes death rates drop because people can now be healthier. If you're ill in a poor country with something as common as diarrhea, you might die from that. Sadly, one of the greatest causes of death for children in sub-Saharan Africa today is still diarrhea. You may chuckle to yourself, but that's, of course, a very sad fact. How are people dying from diarrhea? Well, of course, when your body's got some illness, it responds by trying to get rid of that illness by any means necessary. And often that means getting rid of fluids in your body and nutrients. It's trying to wash out the bacteria or the virus. So if you're a person in a poor area, a child in a poor area with a weak immune system and a body not capable of going long periods without food or nourishment or water, then your body's going to do what it does to get rid of the illness. And in the meantime, that child will likely be going without clean or sufficient food or water, meaning that they'll eventually just basically die from this disease or this symptom because they didn't have adequate food. So food production helps people live longer, having more access to food, just because then your body is more likely to survive periods of disease. It makes you healthier. In addition, of course, we know better medical care directly leads to solving medical problems. If you're sick, you can use better medicine or medical care to fight the disease. And I've already talked about how better transportation can result in higher survival rates. All right, let's move on then to stage 3. Also, I guess I should mention better sanitation and water, more access to clean water. I've kind of already mentioned that. So stage 3, at this point, you've got a lower birth rate and a lower death rate. So what is going to happen here? Well, generally, you're going to see that people will become wealthier and healthier. In stage 3, the birth rate will finally drop because often people are choosing to have fewer children. Governments do sometimes get involved, though. So imagine you've got a country with a huge growth rate. You've got this high birth rate and lowering death rate. This growth in between that's occurring is going to eventually add up to a super fast growing population. And that cannot continue for a very long time. We've kind of already seen how that worked with the world population, where our world population grew so slowly for a long time, and then starting around the mid to late 1700s, it shot up like a rocket. So if that keeps up, we're all screwed, right? So you've got to find a way to decrease the birth rate, and sometimes that's done by force through government intervention or government programs. Sometimes it's done willingly, many times it's done willingly by people. And the major reasons that it goes down, that the birth rate tends to decrease, is because women finally get more opportunities. The more educated women are, the less children they have. That's, of course, not to say that people who have lots of kids are uneducated. Generally, though, the more educated women are, the less children they have. This is because they have more going on in their lives. And there's so many things I wish I could ask you about if we were in class today. But you could even ask yourself, if you are a female, or if you're a male, you could pretend to be female in your head and think, well, if I went to college and spent 4 years and thousands of dollars pursuing a degree, as many people hope to do these days, then why would you suddenly go and have kids when you're 23? You would have to then balance that out with a full-time job, or maybe quit your job to look after the kids, because it's very difficult to do both. And then you would have wasted all that education and the money. So many women, of course, instead choose to invest in themselves. They get an education, they will stay in a job for years and years, maybe not even have kids till they're late 20s or early 30s, maybe even mid to late 30s. That's not as uncommon these days as it used to be. So the more educated women get, the more they end up having something else to do other than this traditional role of having children. Children are also going to become less common in cities that are developing because children are expensive, especially in urban areas. You might think to yourself, well, why would wealthy people have less kids? While poor people tend to have more kids. Totally sensible thought. You'd think, well, kids are expensive and tough to raise, so if you're poor, why wouldn't you choose to have less kids? Well, we've kind of already gone over that. Often poor people are working in farms. They're in circumstances where they don't have the option to have less kids because maybe they don't have access to birth control. Women fall into these patterns because they don't have other options, and this is kind of their traditional role. And since many of them work on farms, they need lots of kids anyway to sort of help toe the line or get the work done. But rich people, of course, like staying rich. And what better way to end how wealthy you are than having lots and lots of kids? Kids are expensive. So rich people who want to stay rich often have less kids for lots of reasons. Not only can they depend on their kids living because they're probably in a place with better medical care, so they don't have lots of kids to begin with because they don't need them. They're also probably not working on a farm, so they don't need kids for that reason. But also, since they're so expensive, why would you have lots and lots of kids? Just have the minimum number that you want, probably 2 or 3, and then things will be fine. This is very common then in urban areas, and this change has happened over a very short period of time. Just as an example, my grandmother on my mother's side was one of 8 children, not uncommon. 70 years ago, 80 years ago, 90 years ago when she was born, more like 100 now. Not uncommon in the early 1900s to be one of 8 or 9 or 10 children or more in the United States. By the time my mother was born, about 70 years ago, she was one of 4 kids. So they went from 8 to 4. And my mother had 2 kids. So we've gone from 8 to 4 to 2 in about 100 years, which is a very short time period. generally when you consider the vast span of human history. Some of you may come from large families, but I'm guessing most of you are maybe from families where you are one of, you could be an only child, you could be one of 1 or 2 siblings. Highly doubt there's many of us that have 7 siblings or more than that. So this is for very good reasons. Your parents, probably your mother, was somebody who got an education, didn't have children until later in her life perhaps, and also your parents don't want to have lots of kids because they're so darn expensive. I've already talked about how parents have to worry less about their kids dying young, and all this results in lowering birth rate over the years that is shown in this chart just over a very short period of time. You can see here in this chart that we've got the birth rate and death rate from 1950 to 2010, and there used to be this huge difference between birth rate and death rate, this big difference right here. It was about double, and so we'd have a 20 natural increase rate, births being 40 and deaths being about 20. Nowadays, while it still looks like the birth rate is double the death rate, the difference is more like 10. So we've chopped the world's growth rate, population growth rate, in half in the last, or in a roughly 60-year time period. And that trend of decreasing growth rates is only going to continue as time goes on. I can't see any reason why this will ever change. The same can be said for the TFR then. TFR is the total fertility rate, which is a term that may not mean much to you, but the total fertility rate, hopefully you know, is number of kids per woman on average. So in the 1950s, women typically had 5 kids per woman on average. And in the 2005 to 2010 period, it was cut in half. These days, if you look at the number, it's closer to 2.4. Wow. So this is a really interesting change. It, of course, tells us that women are probably getting more educated, that families are getting wealthier, that kids are surviving longer, so you don't need to have as many kids. There's so many things that are positive about this. But the farther down it goes, the more concerning it can get, although eventually it will reach this magical number, hopefully of 2.1, which is known as zero population growth. And that occurs in stage 4. On stage 4 for a country or an area, you've got low birth rate and low death rate, which leads to zero population growth. A TFR of a magical number of 2.1 means that you have no growth in your population. It's called zero population growth. You may wonder, yeah, but Mr. Waple, you said that that happens in stage 1 when the birth and death rate are both high, and that cancels them out, so you have no growth. While that's true, that's not the same as zero population growth. Zero population growth is a positive thing, so I'll draw like a happy face here. This is good, because you have now educated women and healthy people, so they don't die a lot. Zero population growth in stage 1 is a sad thing, because you have lots of people who are dying in an unhealthy place and women who have no opportunities generally, so they have lots and lots of kids. So once you finally get to zero population growth in the happy stage of stage 4, and women are having this average of 2.1 kids, they have now reached what's called the replacement rate. This is the number of kids women have to replace the parents. So you may wonder how this works, or how this math is kind of working out. So let me explain. If you've got a man and you've got a woman and they love each other, doesn't have to be a man and a woman, and there's love here, they may then get together and get jiggy with it and have 2 babies. So let's say they have these 2 babies. Great job. Did they grow the population? You may be thinking to yourself, no, but there were 2 people, and now they added 2 people. So of course, they have 4 people. They did grow the population, but hopefully you know, of course, that these 2 parents will eventually kick the bucket. And so they will lose 2 people, and the end result, of course, is that they will be back where they started with 2 people. So the replacement rate is generally 2. You have 2 parents, they have 2 kids, the 2 parents die, and you're left with the 2 replacement kids. So what's the deal with this 0.1? Well, this deals with, or has to do with, the fact that many people choose not to have kids or end up not having kids. For example, maybe you're born and you have a lovely life and then you get hit by a bus before you can have kids. Or maybe you just are unable to have kids, or maybe you choose not to have kids. So that extra 0.1 makes up for these people who either choose not to have kids or can't have kids or die before they can have kids. So every now and then you'll have a family of 2 parents and they'll have 3 kids, And that will still mean that we'll have a replacement of our population rather than growth. Hopefully that makes sense. So stage 4 is where this growth eventually disappears because couples will have only enough children to replace themselves, and that 0.1 accounts for the kids who, or the people who don't have kids or choose not to have kids. Many developed countries are here. The United States basically is here. And this is a very happy stage to be in because you're not growing, you're not shrinking. Things are generally good because people are generally healthy and wealthy. See if you can draw now the demographic transition model in your notes. Try to do this without looking at your notes. Maybe you can even remember the rhyme that would make this work. See if you can get it. Can you get the rhyme and draw this? I'll give you a minute to figure it out and draw the demographic transition model's 4 stages on your own. Go. All right, so hopefully at the very least you've got a y-axis and an x-axis, and you can start out, let's do the death rate just by doing a high amount, and then it goes down, and then it continues going down. And now let's see if we can get a birth rate. We'll do that in green because it's like adding people, and so that's about the same. It'll stay the same, then it too will go down, and then it will be the same. So now let's divide this into our different stages. Wherever the change happens is where a new stage begins. So this is basically stage 1, stage 2, stage 3, and stage 4, thereabouts. Hopefully yours looks something like that, and you'd of course want to label these your death rate and your birth rate. Easy peasy. That's it. I guess we could label our stages as well. So if you got that, hopefully the rhyme worked for you. Deaths decrease or stay the same. This is true till the 5th stage. Births decrease or just remain. And this will never see a change. Hopefully that worked for you. It works for me. All right, let's continue. We're just about done, but we've got to cover this 5th stage, and then we are finished. So this 5th stage is where we see this change happen that was alluded to in that rhyme. We end up seeing deaths for the first time actually end up increasing while births continue to decrease. This creates a challenge that we have not dealt with yet. Up until this point, birth and death rates have either been the same or the death rate has been lower than the birth rate. But now we're seeing the death rate be higher than the birth rate. That's an interesting challenge for many places that are being faced right now, or that is being faced by many places right now. This leads to a shrinking population. When your birth rate is lower than your death rate, you are losing more people every year than you're gaining. So you have a shrinking population. This tends to happen in the most developed countries in the world for reasons we've kind of already talked about. If you have less and less kids every year, maybe some couples will have 1 kid or no kids, then eventually there's no one to replace them. And there's good reasons why you might have no kids. They're expensive. You can still have a happy life without kids. You don't need kids to do farm work. So of course that means that if you have a couple and they have no kids, eventually they're just going to die. So you've got a birth rate of 0 and a death rate of 2, and your population will start to shrink. It can be very bad. So while the features of this are positive, wealthy people and healthy people, everyone dies eventually. And if you haven't replaced them, this can create dire circumstances for that country, generally because the economy will not be growing, it will be shrinking. And governments care about this because they will not get enough tax revenue. So this is a huge issue on a smaller scale. If we change the scale of analysis to the city instead of the country, while some countries do have shrinking population growth rates, the city scale can also be easy to see the problem. Chicago is in this situation, unfortunately, not necessarily because of births and deaths, but also people leaving. Chicago's peak population was in 1955 when there were 3.5 million people in Chicago. Today, Chicago's got 2.7 million people. So we've lost about 1/4 of our population in the last 60 years. So what does that mean? Well, let's say you had a school and this school had 1,000 kids in it, and they were happy kids going to school in 1955. But now this school has lost half of its enrollment, and now it only has 500 kids in this school. Do you need all the teachers you used to have? No, but maybe they're still working there because of union contracts. I don't know. Do you need to light up all the school rooms and keep all the rooms heated and air conditioned? Yes. So a lot of your cost is still going to be the same, even though you have less dollars coming in. So what do? Well, in many cases, like in Chicago, they simply just got rid of some schools. So you have neighborhoods now with no schools. If you have less people paying taxes in your city, do you still need to like turn on the street lights on all the streets? Yep. Do you still need to maintain the roads in all the city? Yep. And you just have less tax money to do it. So imagine this on a much larger scale. How do you solve this problem? What do you do? If it's happening in a whole country, do you raise taxes? You can, but that's going to drive people away. People won't want to come to your city or come to your country if there's higher and higher taxes. So if you do increase your taxes, it's going to actually make your problem worse in many cases. So what else do? Well, you could cut back services. You could close schools and not repair streets as much. Is that going to make people want to come to your city or your country? Probably not. So you can't really cut back services or raise taxes without there being dire consequences. So once a country's in this situation, it's really hard to reverse. And as we've said, the number of kids that people have is a personal choice. How do you get people to have more kids? It's hard to get people to have more kids because they're expensive and people want to have the amount that they want to have. So to get people to have more kids is difficult, and that's generally why birth rates only either stay the same or decrease, whereas death rates can go up. They generally stay the same or decrease, but as we see in stage 5, they can go up because people die eventually. And when you have people in a country that are getting older and not having kids, your death rate will eventually just get higher than your birth rate because there will be lots of old people and not a lot of young people in your country. People will be dying, and there won't be a lot of replacements. So stage 5 is a huge problem for countries. And I think the last thing I will show you, I'll skip that detailed chart because we've already gone over this, is a real version of this. Here's Sweden's demographic transition from 1735 to 2000. So let's stop talking in hypotheticals and look at real data. So here in stage 1, their birth rate and death rate were generally the same. But in stage 2, we start to see a big gap between the birth rate and the death rate decreasing. So now you've got a growing population. And then eventually the birth rate starts to decrease as well as women get more educated, starting around the 1900s, in Sweden at least, until we get to stage 4, where their birth rate, actually I'll undo that, their birth rate, really stage 4 is only this part. Their birth rate and death rate are the same, and then here you actually get to stage 5, a death rate that's higher than the birth rate, and Sweden's population is decreasing. So hopefully that makes sense. You can see this in real life, and we'll stop there. Let me know if you have questions. Hopefully this made sense to you. Have a great day.